Hello everyone, I'm Christina and welcome to the second video in our A-level trigonometry series. In the previous video, we looked at key trigonometric identities that we will be using throughout the course, and in this video, we're going to look at the compound angle formulae. These are extremely useful for simplifying expressions, proving identities, and solving more advanced trigonometric equations. So we'll go through plenty of examples in later videos. But in this video, what you should be able to do by the end of it is state the compound angle formulae for sine and cosine. The second thing is to understand the sign changes in these expressions. What I mean by that is we have sine of a plus b and cos of a plus b stated already, but what if I want the expression for sine of a minus b and cos of a minus b? How will I get those? So we're actually going to derive those together. And then once we do that, we can derive tan of a plus b. And then we're also going to look at how that expression changes if it were tan of a minus b. Okay, so to do that, we're going to need to comment a little bit on our functions. So firstly, our sine function is what's known as an odd function. Which means that sine of minus x equals minus sine of x. Okay, whilst our cosine is actually an even function. So what that means is that cos of minus x is just equal to cos of x. So we'll comment further on this in a later video, especially help us to have the graphs for each trig function next to it to kind of understand this concept a bit better. But for now, let's just use this and our expressions for our sine and cosine double angles to derive sine of a minus b and then cos of a minus b. So let's start with sine of a minus b here. So let me just separate this slightly. So sine of a minus b, well, we can see here our a hasn't changed. It's still positive a. So the first thing we can write is sine a here. But then instead of writing cos of b, like we would have in our first expression there, we now have minus b here. So if we have minus b, we're going to write cos of minus b instead of cos of b, okay? And then we can finish that off by writing cos of a stays the same, sine of minus b. So because we said our cosine function is an even function, cos of minus b is just going to be cos of b, cos b, and then sine of minus b, well, since sine is an odd function, we can see here, if we put minus b inside the sine function, that negative sign will come out in front. So we can rewrite this as sine a cos b, that's the same, minus cos of a sine b, because that sine of minus b is the same as minus sine b. So that's our third expression that we've written down. And that's for sine of a minus b. And now if we want cos of a minus b, we're going to do the same thing, but for our second formula here. So cos of a, that stays the same. Then we have cos of minus b minus sine of a sine of minus b. And let's rewrite that. So cos A, cos of minus B is just cos of B. Then we can write here sine minus sine of A minus sine B, because sine is an odd function. And so let's just rewrite this once more. We have a negative sine A times negative sine B. Well, that's going to give us positive sine of A sine B. So now we have our compound angle formula for cos of A minus B. And that's our fourth expression here. Okay. So now let's derive tan of A plus B. Recall from the previous video that tan of x, or tan theta, is equal to sine of x over cos of x. So then tan of A plus B can just be written as sine A plus B over cos of A plus B. So then if we substitute in the expressions, the compound angle formulae for sine of A plus B and cos of A plus B, we can rewrite the right-hand side here as sine of A cos B plus cos A sine B all over cos of A cos B minus sine A sine B. Okay. So now we have an expression for tan of A plus B in terms of cos and sine, but we kind of want to see what can we divide through each term by to get everything in terms of tan. Okay, and you might want to try it out yourself, dividing through by maybe cos A first or cos of B. But the easiest thing for us to do in this case is divide each term by cos A cos B. So let's see what we get by doing that. So of course, this is still an expression for tan of A plus B because we're dividing each term in the numerator up here and the denominator down here by cos of A cos B. So then tan of A plus B is also equal to sine of A cos B over cos A cos B plus cos A sine B over cos A cos B all over cos A cos B over cos A cos B. That's useful. We can already see that's going to cancel and just give us 1 minus sine A sine B over cos A cos B. Okay, so now we can actually rewrite this because we can simplify. So let's look firstly at this term, our first term in the numerator. Sine A cos B over cos A cos B. Well, sine A over cos A is tan A. Okay, we know that from our previous identity over here. So sine A over cos A is tan A, and then cos B over cos B, well, those just cancel. And then we have the next term in the numerator, cos A sine B over cos A cos B. Well, cos A's cancel, and then sine B over cos B is plus tan B. Over, we have cos A cos B over cos A cos B. Well, that's just 1 Okay, we can see that. And then we have minus sine A sine B over cos A cos B. So sine A over cos A, well, that's tan A. And then sine B over cos B, that's tan B. So we've got tan A, tan B in the second term of the denominator. And so now we have our expression for tan of A plus B. And that is our fifth compound angle formula. Okay, if we wanted tan of A minus B, let's think of how we would rewrite our expression 5 here. So tan of A, well, that term will stay the same because A is the same. Then we have minus B instead of plus B. So we're doing plus tan of minus B over 1 minus tan A times tan of minus B. Okay, so going back to this idea of even and odd functions. So in fact, tan is also another odd function. So tan of minus x is equal to minus tan of x. And intuitively, we know that tan x is sine x over cos x, right? So if I write that just below here, and if sine x is an odd function, so having a negative inside the sine function means that we have a negative outside of it. But then our cos function down here, when we have a negative inside the cos function, it stays the same. You can kind of see that that would then affect the tan function in the same way that it affects the sine function. Okay, but tan x is also an odd function. And that is, again, something that we will look at further in another video. Okay, so we can now rewrite the right-hand side of tan A minus B as tan A minus tan B over 1 minus tan A, and then we're multiplying by minus tan of B. So we've got a negative multiplied by a negative, that's a positive. So we get tan A minus tan B over 1 plus tan A tan B. And so that's the last formula that we're going to jot down in this video. So in the next video, we're going to look at the double angle formulae specifically, okay? So I'll see you in that one.